Alright, let's find the area right here, this shaded area. So this shaded area, it's bound by the equation y equals the sine of x plus 1, and the x and y axis, and x equals 2. So we're going to do the trapezoid rule to find the area, and we're going to break the intervals into 4 equal spots. So we've got one interval right here, one right here, one right here, and one right here. There's a little table here at the bottom I'll show you in just a second that we're going to use to help us. But just in case you're not sure with how this trapezoid thing works right here, there's some ugly formulas. But I want to show you what those formulas are really getting at. What those formulas are trying to do is they're trying to help you find the endpoints of a trapezoid like this one right here. Because what you're going to do is you're going to find the area of this trapezoid right here, and you're going to find the area of this trapezoid that's going to be bound right here by these corners, right? These are the endpoints. This one, and of course the last one over here. You're going to find 1, 2, 3, 4 trapezoids. 1, 2, 3, 4 trapezoids. You're going to add them up. You add the area of each of those trapezoids up, and that's going to give us a fairly close approximation to the area of the whole thing. So, key piece of information is the formula. 1/2 of the height times the sum of the bases. Now the thing is, the height is the perpendicular height and the bases are parallel, always, with the trapezoid. So these are the bases. They're actually going vertical and the height's going this way. So the height for each of these is 1/2. You see? Alright, so now we have to find this point, this point, this point, this point, this point. Now this one's sine of 0, well that's just 1. Well it's 0 plus 1, right? So sine of 0 is 0 plus 1 is 1. So that's how we're going to find these points right here. We're going to take this, and we're going to plug it into the function to see what the output is. And that's going to help us figure out the other height. So right now, we have endpoints 0 and 1/2, right? The first height we know is 1, but we don't know the second height. So we've got to figure that out. So we're going to use this handy dandy calculator here to do just that. Enter. So we're going to start with that hotness right there. So sine of 0.5, make sure we're in radians, right? 0.5, and then of course we could do this in our head, but just to make sure for due diligence, 1.48. We're going to round to, we're going to do 3 significant figures. So this is 1.48 right there. So that means the height right there is 1.48. So that's enough information. So 1/2 times 1/2. So 1/2 of the height, right? The height is 1/2. So 1/2 of 1/2, and then the sum of the bases. So 2.48. Right? So 2.48. Well, it's going to be 0.62. So 2.48 divided by 4, of course, 0.62. There we go, 0.62. That's the first one. So this one right here has an area of 0.62. Let's go ahead and continue on and fill out the rest of these right here, right? So we know we have to figure out this point right here, but we're going to go ahead and fill out the table. So for the next endpoint, we know that it starts at 1/2 and it goes to 1. We know the first height is 1.48. Now we need to figure out what is the point right here. To do that, we're going to do the sine of 1 plus 1. So sine 1, and we'll just add 1 in our head, right? So 1.841, so 1.84. Let me double check that. Yep, 1.84. 1.84. Kind of funny because it's kind of turned around right there, right? So what we have here, even though you can maybe do this calculation in your head, it's good to write it out, because if you made a silly mistake, the easiest way to find it is just like that right there. So we have 1.48 plus 1.84 divided by 4.83. There we go. Alright, moving on. 0.83. So there we go. Sorry if you couldn't see me right in there. I thought, never mind. Anyway, so let's go ahead and move on. This next one is 1. This is 1.5. Those are endpoints 1 and 1.5. We know that this first point right here is 1.84. 1.84. So now we have to figure out what is the next one. It looks like it's 2. Looks like it's 2. Turns out it is 2. We're going to plug in 1.5, right? So sine 1.5 plus 1. When you round it, it's 2.0, right? Because we're going to round 2.0. So here's what we've got. We've got 3.84 divided by 4. And the reason, again, it's divided by 4, it's 1/2 times 1/2. Right, so 3.84. 0.96. Okay. Last one. Goes from 1.5 to 2. Now we know that this first height is 2. We got to figure out what this point is right here. The way we're going to do that, we're going to plug in 2, right? Just to make sure. Sine 2 plus 1. So sine 2 plus 1. 1.91, because we're going to round, right? 1.91. There we go. So we have 3.91 divided by 4. 0.977, so that's 0.98. Now we have to add these, and that's going to give us our total area. So we've got 0.98 there already. Let's see here, plus there we go, 3.3875. So if we round that to 3 significant figures, what we're going to get a total area approximately, right, using that approximation symbol, 3.39. Yeah, there we go. So I hope this has been helpful. That's how you do it. Find the area of each trapezoid. But I figured, hey, let's go ahead and, since we're here, let's go ahead and take a look at a graph while we're at it and see just how close we were. So let me open up a graph right here. I'm going to go ahead and just I'm going to go ahead and close all these graphs. There we go. Do I want to save? I do not. Alright, fresh graph. So we're in degrees, so we have to change that. It's kind of not that big of a deal if I remember how to do it. We go to menu, then you go to number 9, and what we want radians. And don't know if we really need that one. Radians, perfect. Okay, so we're doing sine of x. X is down there, plus 1. Enter. There's our graph. So now let's go ahead and do an analysis of our graph. What we're going to do is we're going to find the integral, number 6, and our lower bound is 0, and our upper bound number is 2. 3.42. So we're pretty close. We're actually a little under, but there we go. 3.42. 3.42 is the actual. So I hope this has been helpful, and hope you have a good day.